Hello. Today we are going to be talking about x and y intercepts of a parabola. Please feel free to pause the video or watch it again so that you understand all the concepts. The y-intercept is the place where the parabola touches the y-axis. This is the place where x equals 0. So if x equals 0, then we can find the y-intercept by plugging in 0 for x. So anywhere I see an x in this equation, I can plug in a 0. So 0 squared minus 8 times 0 minus 48. Now the nice thing about plugging in 0 is that it's easy to work with. 0 squared is 0. 8 times 0 is 0. And then you see that 0 minus 48, you get your y-intercept quickly. It's negative 48. Now looking at this equation, we didn't have to do much mathematics. In fact, we could have just looked at the last number without the x and saw that that's always going to be our y-intercept. So our y-intercept, if we're given an equation in standard form, ax squared plus bx plus c for our quadratic function, our y-intercept is going to be this last number. It's going to be c. So we would say our y-intercept is always going to be 0 for x and c for the y. And all you have to do is look at the last number of the equation to figure it out. In this case, it was negative 48. Now let's work with the same equation to try and find the x-intercepts. Now, like we talked about in the previous section, the x-intercepts are the places where the parabola touches the x-axis. Now, in the last section, we were able to solve for x because we just had an x squared in the equation. In this case, we have more than just an x squared. We have an x squared and an 8x. So we can't combine these together because they're not like terms. This one has an x squared and this one's just x to the first. We can't combine them together. So it's going to be impossible for us to directly solve for x without using a different method. So when we solve and we have an equation like this, the next step would be to try and factor the equation. That gives us the ability to solve for x. So let's start by factoring the equation. We can use the box method. We draw a box, put the first term in the first box, x squared. You put the last term, negative 48, in the last box, and then you multiply diagonally. X squared multiplied by negative 48 is negative 48x squared. So what we're doing is we're going to look for two numbers that multiply to give me negative 48, but add to give me this middle term, which is negative 8x. In this case, we can figure it out. We know that it is negative 12x and positive 4x. So we take that negative 12x and the 4x, and we put it in the box. It doesn't matter which order you put them in. And then you factor. Well, what goes into both negative 12x and negative 48? That's 12. What goes into both x squared and 4x? That's x. X squared and negative 12x is x. 4x and negative 48, that's 4. We can double check by saying, does x times x equal x squared? Yep. 4 times x is 4x. X times 12, that's not negative 12x, but I can make the 12 negative and then the problem works. And 4 times negative 12 is negative 48. So our two factors are x minus 12 and x plus 4. Now we're not quite done yet. When we're trying to find the x-intercepts, again, it's the place we talked about the day before where the y value equals 0. So what we're going to do, our next step in solving from factored form, is to set each of these two little baby equations equal to 0, because we want y to be equal to 0, so that we can solve for x. So we would say that x minus 12 equals 0. And then all you have to do is add 12 to both sides. And we can see that x equals 12. It's hard to see there at the bottom. You also can take this x plus 4 and set that equal to 0. minus 4 from both sides, we get that x equals negative 4. Now, what we can see is some pieces of the parabola start to come together. We have two x-intercepts. One is at positive 12 and the other is at negative 4. So we can graph those. Negative 4, here's x equals negative 4. Here's x equals positive 12. We know that the parabola is going to touch both of those. Furthermore, we know that the number in front of the x squared is a positive 1, so we know that our parabola is going to open up. And we found on the previous slide that the y-intercept is negative 48. So somewhere down here at negative 48, the parabola touches the y-axis. And that gives us a good picture. We know the parabola is going to open up. It touches at negative 48 and then also starts at positive 12, goes through negative 48 on the y-axis and touches at negative 4 on the x-axis. This helps us get a picture of what the parabola looks like if we didn't have a graphing calculator. So let's try one more example of factoring to find the x-intercepts. So let's start to find the x-intercepts of x squared minus 12x plus 36. So again, because we're going to factor, we can't solve this directly because it has an x squared and an x in it, so we know we need to factor. That's our clue. Draw the box. Put the first term in the first box and the last term in the last box. Now, when I multiply these, I get 36x squared, and I'm looking for two numbers that multiply to give me 36x squared, but when I add them, I get negative 12x. Now, when I know I'm multiplying to get a positive but adding to get a negative, I know these two numbers have to be negative. And in this case, they're both going to be negative 6, because negative 6x and negative 6x multiply to give you a positive 36. But negative 6x and negative 6x, when you add them, you get negative 12. So we can go ahead and put those in the box. Now we can go across and factor. Going into both negative 12x and 36 would be 6. Going across this way for x squared and negative 12x, the only number that goes in is just x. Going up, the number that goes into both x squared and negative 12x is just x. And the number that goes into both negative 12x and 36 is 6. So let's make sure that it works. X times x is x squared. 6, oh, not 6. It's actually not 6. So what we need to do when we have trouble where, did you see that x times 6 is not negative 12? We have to reevaluate. And that's okay to make mistakes, because I kind of did this so that you could see it's okay to make mistakes. There's obviously a bigger number that goes into both negative 12x and 36. In this case, it would be 12. And you can check that. Does 12 times x give you negative 12x? Yes. Well, if it was a negative 12. And then x times negative 12 is negative 12 as well, so we know that this is going to work. Therefore, our two factors are x minus 12 and x minus 12. Again, we're not done. We have to take these factors and set them equal to 0. X minus 12 equals 0. X minus 12 equals 0. The thing is, in this case, when we add 12, we get x equals positive 12 as one x-intercept. Same thing here. We see that the x-intercept is the same in both cases, 12 and 12. It does not mean that your parabola goes through the x value of 12. It doesn't mean that the parabola goes through 12 twice. It literally means that your parabola is sitting on top of the x-axis, touching it right there at x equals 12, one x-intercept. Okay, so there's only one x-intercept in this case. A lot of cases you'll have 2x intercepts. This is one example of one. So please feel free to watch this video again. Remember how to factor, and good luck.